Okay, in this video we'll be talking about density. This is for GCSE level. And a little question or challenge that you could think about while we're going through the video is imagine this situation. We've got a bathtub and it's full to the absolute brim with water. And it's got a really large iceberg floating in it. What happens to the level of the water when the iceberg has melted? So in today's tutorial we're talking about density. By the end of it, you should be able to recall and apply the equation to calculate density. You should be able to use the particle model to explain differences in density or different states of matter. And you should know how to experimentally find the density of solids and liquids. Any questions, bring them to the next lesson or email them to me. And remember to use the pause button as you go through, and you can rewind to watch things again. So first of all, let's remind ourselves of the equation for density. We've seen this before in Key Stage 3, probably in Lower 4 or Year 8. So the equation is density is equal to the mass of the object divided by its volume. And if we see that equation in symbols we've got this equation here, so rho equals m over v. If we have a look at the units now of these different quantities, volume v is measured in meters cubed. The mass of the object is going to be measured in kilograms, and the density therefore is going to be given in kilograms divided by meters cubed. So we need to take a moment and remember what we know about the particle model for different states of matter. So in just a moment I want you to press stop or pause on the video and see if you can draw out how the particles are arranged in a solid, a liquid and a gas. Think about making the particles all the same size and think really carefully about the important points that we learned earlier in school about how the particles are arranged. Okay, so I'm going to draw these in now. If we have a look at the particles in a solid, they're going to be arranged in neat rows and columns, and they're all going to be touching each other. So we might have something that looks like this. If we have a look at how the particles are arranged in a liquid, they're going to be touching each other, but they're not going to be in neat rows and columns. They might look something like this. And if we have a look at how the particles are arranged in a gas, they're going to be randomly arranged and they're not going to be touching. They're going to be really spaced out. You also get an extra mark if the particles in all three diagrams are the same size. Now we can use this particle model to start to predict what we would expect to see in the densities of solids, liquids and gases. As you can see, the particles are arranged more densely in a solid, so we would expect normally solids to be more dense than liquids, and we would expect solids and liquids to be much more dense than gases because of the way the particles are arranged. Right, so now let's have a look at how to find the density of solids and liquids. We're going to start off with liquids. You're going to need two pieces of equipment for this. You're going to need an electronic balance that can measure the mass, and you're going to need a measuring cylinder that can measure the volume of a liquid. So the first thing we're going to do is put the empty measuring cylinder on the electronic balance and find its mass and tear the balance to zero, and then you're going to pour in the liquid that you want to find the density of. So measure the mass of the liquid. You have to take away the mass of the empty measuring cylinder from your total mass to find the mass of the liquid. To find the volume, you're just going to read it off on the scale of the measuring cylinder, and then we need to convert the units. Okay, so let's say we've been taking these measurements to find the density of liquid, and let's say that the mass, it turned out was 20 grams, and the volume, as you can see here from the measuring cylinder, was 20 millilitres. Now we have to convert the millilitres that we've got here into centimetres cubed and then into meters cubed. So we know that 1 millilitre is equal to 1 centimetre cubed. And we also know that 1,000 millilitres is equal to a litre. And we need to remember these things when we're converting units in questions within the GCSE. But this bit and this bit to remember is pretty simple. But the bit that we really have to concentrate on is if we're converting centimetres cubed into metres cubed. So let's go through that now. If you imagine that you're converting a centimetre cubed into a metre cubed, so I'm going to draw out first of all a metre squared. So let's say this was a metre squared, so this was 1 metre here and this was 1 metre here. And so you could almost think of that as 100 little centimetres all lined up that way and 100 little centimetres all lined up that way. So you'd get a 1 centimetre cubed just here, 1 centimetre squared just here in this metre squared. So if we then think about what that means in terms of how many centimetres squared there are within a metre squared, we'd have 100 centimetres along here and 100 centimetres along here. So overall, we're going to have 100 times 100 centimetres squared in 1 centimetre squared. So that's going to equal, let's rub that out there. Let's make this a little bit bigger. So we would have 100 times 100 centimetres squared equaling 1 metre squared. But we are doing metres cubed, so if we then turn this into a cube here, we then also have 100 centimetres going back that way. So for 1 metre cubed, we've got 100 times 100 times another 100, so we've got 100 times 100 times 100 centimetres cubed equals 1 metre cubed, and that is going to be that. So we've got 1 million centimetres cubed within 1 metre cubed. So if you, let's say you had 20 millilitres here, that would be 20 centimetres cubed. So we've gone from millilitres to centimetres cubed. So we've got 20 centimetres cubed. And then to turn that into metres cubed, we have to divide it by 1,000,000 to get it into metres cubed. And then obviously the mass here, rather than being in grams, we want to turn that into kilograms. And then we can find our density in kilograms per metres cubed. So now we're going to look at how to find the density of a solid. There are 2 types of solid that we have to be able to find the density of. A regular solid, and that is a solid that has a shape that you might learn about in maths. So here we've got a cylinder, here we've got a cuboid, you could have a cube, you could have a prism and so on. There would be an equation to help you calculate that volume that we would learn about in maths. So when we talk about these regular solids, they're ones where we could use an equation to calculate it. Irregular solids we're going to look at next. They're strange shapes that you couldn't use an equation to calculate. So let's have a look at what we do here. The mass we're going to measure with an electronic balance. So you just pick up this object, put it on an electronic balance, find its mass, make sure you've converted to kilograms. To find its volume, you're going to measure the dimensions of the solid. So if we were looking at this cuboid, I would measure the length, I would measure the width, and I would measure the height. And then I would use the mathematical equation to calculate the volume. So here on this one, I'd multiply the height by the length by the width, and then I'd get that volume, and then I'd put both of those into density equals mass divided by volume. A couple of things to bear in mind now we're doing GCSE. If you measured these in centimetres, convert them to metres before you times them all together to find the volume. And most importantly, make sure you're using the right piece of equipment to take these measurements. So whereas before we would have always used a ruler, you might want to now start thinking about using a vernier caliper or a micrometer to take these measurements. because they're going to give you a little bit more precision. And you also want to think about taking 3 repeat readings. So if we were measuring this length here, we would measure the length of this cuboid in 3 different places, and we would take an average. And we would measure the width along here, along here, along here, in 3 different places and take an average. And the same with the height. And it's really important that if you had to do a calculation like this in an exam, that you make it clear somehow to the examiner that you have remembered to take 3 different measurements and take an average. So now we're looking at how to find the density of an irregular solid. So that might be something like a rock or a pebble or a strange little toy, just anything that's a strange shape that you can't calculate with an equation. Some bits are going to be exactly the same. So again, we're going to measure the mass with an electronic balance. Just put it on top and find the mass. Make sure you convert to kilograms. To find the volume, we're going to see how much water it displaces. So here you've got a measuring cylinder that had a certain amount of water in it and no object. You add the object, it's fully submerged, and then you read off the new volume of water, and the difference between those 2 readings, the volume of water displaced, is the same as the volume of the irregular solid. So we can do it like that. There's another way if you don't have a measuring cylinder that this object will fit into, and that's involving something called a Eureka can, and we'll be talking about how you can make your own Eureka can at home in the next slide. But other than that, it's exactly the same. You're putting these 2 measurements of the mass and the volume into the equation for density, which we know is density equals mass over volume. And you're going to want to think about converting this volume here that's in millilitres into centimetres cubed and then into metres cubed, as we discussed earlier in the video. Okay, so the next thing we're going to do is we're going to try and do a version of this experiment at home. Obviously, we don't have any lab equipment available to us at the moment, but this is an experiment that you can do at home. But do just make sure you're using waterproof objects. I'm using this empty jam jar here, and make sure you do ask permission from an adult or guardian. So here's the equipment that you're going to need. I've got just some baking scales, some electronic scales I use here. I've got an enamel tray to collect water in. I've got a measuring jug that I've put that fits in the enamel tray, and I've got an object that I'm going to try and find the density of. Here it's a jam jar with a lid. It's empty and clean. So the first thing I'm going to do, I'm going to measure the mass of the jam jar. Here is this image here, and you can see it's reading 169 grams. And we can convert that into kilograms now before we do anything else. So if we convert that into kilograms, we're going to get 0.169 kilograms. Okay, so the next thing that I do, I want to find the density of just the components of the jam jar. So I don't want any air inside it, so I've taken the lid off, as you can see here. And what I've done is I've got my measuring jug inside my tray to catch all the water, and I filled it right up to the brim, so that with water, so that if I added a single drop more water, it would fall out of the side into the tray. So when I had my jug brim full of water, I then put the lid of the jam jar in and the empty jam jar, and they sunk and they went under the water, and the water that was pushed out of the jug collected in this tray here. Now what I then did was, very carefully, I poured this water into a separate container to find out how much of that water I had, because the volume of this water is the volume of the jar and the jar lid. So that's what we need to find next. We've got the mass, next we need the volume. So I need to find this volume here. Now it's pretty hard to see in this photo here, just because of the light level and the catch, but actually the water level is just here, yeah, in my measuring jug. And I checked it on the scale, so I've got 154 millilitres, so we can write that in now. So in terms of the volume, I had 154 millilitres. So let's start converting that. So I've converted 154 millilitres into 154 centimetres cubed. And then to convert the centimetres cubed to metres cubed, I've divided by a million, so I've got 154 divided by a million, and that gives me a volume of 0.000154 meters cubed. And if I then put those two figures into my equation for density, I get 0.169 kilograms divided by 1.54 times 10 to the minus 4. That's all on the underneath of this sum here. And if I find the answer to that, I get 1,097 kilograms per meter cubed. So then what I decided to do was do the same experiment, but this time I want to find the density of the object that is the jam jar with the lid on. So it's got the same mass as we had before, 169 grams. But when I submerged it in the water, I had the lid screwed on, so it was full of air. So obviously that object should be less dense. In this case, I had to just push it with my fingertips just so that it was fully submerged. And I collected all the water that was displaced again. And I poured that water into a jug, and I took the measurement of the jug, and I checked it on the scales, and I got... So you can see the water levels just in there. Just there. And by checking the mass on the scales as well, I know that I've got 268 millilitres of water. So the volume of water displaced by the object was 268 millilitres, which means the volume of the object was 268 millilitres, which converts into 268 centimetres cubed. If I now convert that into metres cubed, so I've got a volume in metres cubed of 2.68 times 10 to the minus 4 metres cubed. I know that my mass is 169 grams, and if I convert that into kilograms, I've got 0.169 kilograms. And so now I can put these both into the equation for density that we've been using. I get 0.169 kilograms divided by 2.68 times 10 to the minus 4 meters cubed, and that gives me 631 kilograms per meter cubed. So you can see those two different densities are different between the closed jar and the jar without the lid on, and we're going to talk about that a bit more now. So if we now compare these two different scenarios, we had the jam jar that didn't have the lid on, so the water went inside it, so it was just a jam jar lid at the bottom and the jam jar, and that had a density, those objects together had a density of 1,097 kilograms per meter cubed. And then when we put the lid on the jam jar and sealed it tight, so it was like a whole object with air inside, its density we found was 631 kilograms per meter cubed. And we can use those two numbers to understand why one is sinking and one is floating. So the density of water is just shy of 1,000 kilograms per meter cubed. So it varies a little bit with temperature and whether things are dissolved in it and so on. But roughly it's like technically like 997 kilograms per meter cubed. So let's say it's 1,000 roughly. If we're looking at whether something sinks or floats in a fluid, if an object is more dense than the density of the liquid, it will sink. If an object is less dense than the density of the liquid or fluid, it will float. So you could have a whole load of different objects with different densities, and they could all be lined up, and all you needed to do to predict whether they were going to float or sink was compare their density to the density of the liquid that you were going to float them in. And if they're less dense, they'll float, and if they're more dense, they'll sink. And if you had two different liquids, let's say salty brine water, and you wanted to know which one would form the top layer and which one would form the bottom layer, you just look at their density. The least dense one will be on the top, the most dense one will be on the bottom. So if we have a little recap about what we were trying to do in this tutorial, we needed to make sure that we could recall the equation for density, apply the equation to different situations, and remember the units. The density equation is one that's not going to be given in the exam, so we do need to remember it. We needed to be able to use the particle model for how particles are arranged in a solid, a liquid and a gas, to explain why solids, liquids and gases are different densities. And we need to know how to experimentally find the density of liquids and both regular and irregular solids. So check that you're happy with all those three things. You can always rewind the video, go back to the bits that didn't quite make sense, ask me questions on the question document that we've got going during the lesson and so on. Make your summary notes if you find that helpful. You've got the class notes to go with this video as well on the Google Classroom. And let me know if you have any questions, and then follow the document in terms of what to do next in the lesson. Hope you're all safe and well. See you soon.